talk about it from zero to huge. We're going to be talking about it from the mere beginner, someone who still doesn't know anything about animations in SolidWorks, and we're going to try and make every one of you at the very end of the session a hero in animations. All right. So obviously this wasn't going to be possible without the active community in Uganda. So a big shout out to them. So this is a bit intro about me, but I believe Medard has already done a great job at introducing me. So let's just get on to the topics that we're going to go through today. So first things first, we're going to talk about what motion studies are in SolidWorks in general, and why should we actually use them, and how can they actually benefit us. And then we're going to talk about the different types of motion studies that exist in SolidWorks, and like do a small comparison between them. After that, we're going to talk about each type on its own. So animations, we're going to talk about it and it's on its own, and the different techniques that we can do using animations. And the same goes for basic motion. We're also going to talk about different techniques that you can use within basic motion. And at the very end, we're going to talk about how to export your models as animation videos, and how to start using that in a good way, and to present it in a nice eye-catching way. So without further ado, let's start with why use motion studies. And the first thing that comes to my mind is it's eye-catching. All right. So if I want to show you something, all right, I can show you in many different ways, but the way that catches your eye, and if you, let's say you're scrolling on LinkedIn or on Facebook, if you see an animation, you always stop to see what it is, because it's always something intriguing, it's something unique, right? So that's the first thing. It just draws attention to your projects. All right. The second thing is, mostly when you do a model, it's usually something that has motion in it, right? So let's say, for example, the image that you see on the screen right now, most of you might not know what that is just from that still photo, but as soon as it starts animating, you understand what that mechanism actually does. So to just sum it up, when you do animations, you're actually providing more details and more information to whoever's seeing the animation, telling him more about your model instead of just showing him one still image at a time. And the next thing is, sometimes models have different angles to be viewed from, and each angle shows you different things about the model. So for example, here one angle shows one word, from the other angle you see another word. So that's just a small example. Another example might be something that has intricate details that you want to show, and specifically show those details while presenting your model. So an easy way to show the whole model, and as well as that show the details, is to use an animation where you can zoom in and move around the cameras and stuff like that, just to make sure that you convey the real depth of that model. So you can also do it to have fun. So look at this video. It was as if I was scrolling on Facebook and I just zoomed in and saw the word SolidWorks, so I had to look at it. And believe it or not, all of this video was created inside of SolidWorks. Right, so nothing else was used. No After Effects, not Adobe Premiere, no other software. It's just SolidWorks was used to create this animation. So what I just want to say is, the limitation is your imagination. Right, so whatever you think that you can do using the tools that exist within SolidWorks motion studies, you can use them and create such wonderful stuff. All right, so now let's talk about motion studies, right? So we said that there are different types: animation and basic motion. There's actually a third type, which is motion analysis, but that's only for those who have SolidWorks Premium. So we're not going to talk about it today. We're just going to talk about animation and basic motion, both of which exist in every version of SolidWorks, whether it's SolidWorks standard or professional, whether it's a student edition or a commercial license. All of them have animation and basic motion. So the main differences between both of them is what the software does and what you give it in terms of information and details. So when it comes to animation, it's based on one of two things: either key points or motors. Right, and key points, you can think of key point as a moment, a freezing moment in time, where you just tell the software, hey, fix this object at this position. And that's a key point, right? And then after like 2 seconds or something, you change something about that model and you say, that's a new key point. And you tell the software, between those two key points, I want you to do something called interpolation, or movement transition between those two key points. All right, and here you only specify the key points, and the software does the transition on its own. The other type is based on motors. So, for example, instead of saying, hey, I want this axe to be at 0 degrees and then rotate it by 360 degrees, no, I can just add a motor to that axe and just tell it, hey, I want you to revolve, let's say 60 times per second, or 60 RPM, and it's going to do that for me. So these are the two main ways inside of animations. On the other hand, basic motion, it's more like simulation, right? Because here it's got physics involved, whether it's gravity, whether it's contact, that kind of stuff. So it's usually, when you talk about simulation, it's usually computationally intensive, and it might take so much time to calculate and that kind of stuff. But that's actually when it comes to motion analysis. But basic motion is like a stripped down version of that, where it's got some sort of physics based on it, but it doesn't take that much time to get your animations calculated and that kind of stuff. So it's like a balance between animation and motion analysis, where it still does have some of those aspects that you have in animation, and it also has some aspects of simulation and physics that's in motion analysis, but it's like in between both of them. So what does that mean to me? What it means is that before I start making an animation or a basic motion, I must decide first which one of them to go to. And the main difference is what I provide versus what the software provides. So when it comes to animation, I specify the inputs to the software, and I also know what the outputs that are going to come out of it. On the other hand, when it comes to basic motion, no, it's actually quite different. You only tell it, here are the parameters that you're going to work with, and let it calculate it and show you the real simulation results or the real physics-based results based on that. So let's start with animation. Animation, there are many techniques to make an animation inside of SolidWorks, and they differ in terms of the complexity and the things that you can do with each of them. So let's talk about key points and start with that. And the easiest thing is just basic dragging, right? So with your mouse, you start dragging components around. So let's head into SolidWorks and see how that can be done. So here I've got a quick animation that I want to create, and most of you might know this trick. It's actually a neat trick where you've got a chocolate bar, and that chocolate bar is supposed to rearrange certain pieces of it, and you feel that a certain piece went missing or something like that. So what I want to do is something like this. If I play this animation, I would just want to move these components around, right? So let's just create a new motion study and start from scratch, right? And here, if I'm talking about just dragging components around, so what I'm going to do is inside of this motion manager, which is where the animation is created, as you can see, I've got a list of components over here, and this is my time bar, which shows me the time throughout the animation. So let's say after 2 seconds, I'm going to stop at 2 seconds, and I'm going to drag this component down. Just like that. Okay, all the way down like that. You notice that there's this blue rhombus that's created down here. That's the key point, right? So now, as you can see, this green change bar, it shows me that this part has changed from here to here. And if I click play, as you can see, SolidWorks now does something called interpolation, transition between when it was at this position and when it was at this position, right? And now I can keep moving on and on. So let's say, for example, at 4 seconds, I want this component to move, or let's keep with this. Let's move this to the side. So let me just drag it to the side over here. And as you can see, I've got another key point and another change bar over here, right? And I can keep going over and over again, and I can keep doing this. But the issue is, it's not really that precise, right? Because I'm moving things with my mouse. So let's say, for example, I go to 6 seconds and I want this now to go all the way down here. Maybe something like that, right? But I still have this part which I want to hide. So I'm also going to go to this delete me part, and I'm just going to right click and click hide. And now it's hidden, right? And I've got the change bar that shows that, and so on. So now if I play from the very beginning, it starts moving like this, like that, and it goes down. all I have to do now is this big part, I have to move it to the side. So I'm also going to do that. So I'm going to start over here, and notice that I've got some mates that fix these parts into position. So I'm just going to suppress these mates for real quick, so they don't affect what I'm doing. And now I'm going to drag this component around, all right? So let me just suppress this mate as well. And just like that, I can start now moving the component. So let's say at 4 seconds, I want this to come over here, just like that. And now if I play the animation, this moves down, this moves to the side, the other one moves to the side, and so on. And you see, it's quite janky. The movement isn't that neat, and it's not really that good, because I don't have much precise control. All I'm doing is just dragging things with my mouse, and that's not really what I want. What I want is to start using numeric control, right? Because let's say, for example, I want this. Okay, it comes over here. If I zoom all the way down here, it's not really exactly what I want. So I might actually start dragging it a bit more until I think that it comes where it needs. But as you can see, there's still a bit of an error over here. So it's just not, it's not a right way to do it. It's just a mess, right? So the other way is to do it using mates, right? And when it comes to mates, now you've got full numeric control over things. So let's say, for example, I'm going to do this once again. Here's a new motion study. Okay, a blank slate. And now I want to use these mates that I've shown you down here, the limit distance mates. So these are mates that have values, and I can change those values along the way. So for example, this limit distance 4 mate, all right, that controls one of these parts, and the other one controls the other. So let's say at 2 seconds, I want to start moving this one. So I'm going to open its mate, this mate, and all I have to do is just double click on the mate, and I'll find this distance. And I can now choose a new value. So let's say 40. All right. And as you can see, the part is going to move around. Okay. And I want to change the other value as well. So I'm also going to open this one and double click. Or I can right click and edit dimension. All of these different ways to do the same thing. And also I'm going to change this to something like that. So now I've created is, now I've got these parts moving around, controlled by the mates. But the real issue right now is that, as you can see, it's like moving through it, because I want one to move and then the other. So what I can do is I can start changing the position of each one of these. So let's say, for example, I want this to start first, and then I want this to start after it. So if I do it like this, you notice that it doesn't work over here, but it also starts working before that, right? And just unsuppress this real quick. So now what happens is that this starts moving first, and then it starts moving to the side. All right, let me hit calculate. As you can see, one by one, it starts moving like this. And I can keep going on and on and on, precisely positioning each component exactly where I need it to be. And it doesn't have to be a limit distance mate. It can be an angle mate. It can be a path mate. It can be any kind of mate that supports numeric control, where you're going to input a value, and then based on that value, the software is going to change the position of your components. So that's the easiest way to start moving things around. But that actually enables me to do more things, which is camera movement. Because when it comes to cameras in SolidWorks aren't actually used that much, because people usually just try to make it the easiest way, and the easiest way isn't always the best way. So as you can see in this model, as you can see, this is the Adobe Reader logo. Most of you might already know it. But the thing about this model is that when you look at it from different angles, it shows you a totally different story, right? So that you actually don't see that when you're looking at it from the front. So I want to create an animation where it actually shows you that model from different angles, where it shows you the different views of that model. So one thing I can do is start by creating a camera. So if I go over here to the to my scenes, lights and cameras, I can right click on camera and add a camera. And now I've got two things. I've got this screen on the right and this screen on the left. What the difference between them is that this one on the left, this is my model view, and this one on the right, this is my camera view. This is what my camera sees. And I've got two things here. I've got this yellow dot over here, and this is where the camera is. So if I move this around, it changes where the camera is. And on the other hand, I've got this red dot over here, which is where the camera is looking at. So I can move this around and change where the camera is looking, right? So what I can do now is I can specify also from this command manager, from this feature manager on the right property manager, I can show the numeric controls. I always love that. And let's say I want to set where the target point is, which is this red dot over here. So let's say I want it to be at the origin, all right? Maybe the origin is a bit too low for me, so I can say, let's say a couple of, let's say half a centimeter above it. That's right. So now it's centered within the image. I can also change where the camera is. So let's say I want it to be like 10 centimeters away. Maybe that's so far 7.5. That's slight. I've got also control over the angle. So that's something I'm going to use as well. So let's set this for now at like 0. And later on, I can start changing it throughout the animation. And I've also got the vertical as well. And I can also change other things, like, for example, the camera rotation. So if the camera is going to be rotating or not. And I can also change things like perspective. So I can turn off perspective totally, or I can turn it on. And when I turn it on, I've got tons of things to change. So let's say, for example, I want it to be a wide angle lens, or maybe a telephoto lens, which is very zoomed in, and so on. All of that I can change from here. And the final thing is, of course, the aspect ratio. So this aspect ratio is kind of weird. So let me just try and choose something else, maybe 16 by 9. So there it is. Maybe I want to input it by myself, so 16 by 9, like that. All right, and I've got full control. Maybe in this example, I make it square, so like it's 1 by 1. All of that I can change inside of my camera, right? But after doing that inside of my camera, now let's head over and create a motion study. So in my motion study, now I can start specifying where that camera is and change those parameters as I move along. So as you can see in this animation I already have here, all I'm doing is just changing where the camera is and its properties. And you can see that if you open this folder, lights, cameras, and over here you can see my camera, and I've got different key points specifying different changes in this camera. All right, so right now I'm working on camera 1, which I already had. If I want to switch to camera 2, all I have to do is just right click on this orientation and camera view key point and say replace key. And it's going to replace it with the one I'm in right now. So first things first, let's just activate my second camera. Here's camera 2. And when I right click replace key, now I've activated camera 2, as you can see with this orange bar down here. So if I play, it's not going to do anything with camera 1. It's only going to focus on the second camera, which I've activated right now. And now what I can do is, let's say after 4 seconds, I'm going to right click and edit its properties. And let's change everything, you know. Let me say I want it to look a bit to the side. I want it to look from a different angle, like this. I want it to change the aspect ratio, maybe, or let's change make it a wide angle, or maybe telephoto. Let's go with wide angle. That's better. And I can even change the aspect ratio. So let's make the aspect ratio 16 by 9. So I can actually change everything, right? And as you can see, I've got this new key point. Let's drag it to the very end. And if I play now, from the very beginning, here it is. You can see that the aspect ratio is changing. The camera itself is changing, where the model is, the model itself. All the changes that I've done with regards to that camera is all changing in the animation, okay? So now that I've used my key points to drive different things, I've drived where the components are using mates. I've drived where the camera is using key points, and I can also change appearances and display styles. All right, so let's take a look at this. Let's say, for example, you've got a component and you want to see things inside of that component. So for example, I've got this part and I want to start looking at things inside of it. So let's start a new motion study. And from here, let's say after 2 seconds, I want this top part to be transparent, right? So I'm just gonna right click on it and click, maybe I want to hide it completely. Maybe I want to change the display. Let's make it wireframe, all right? And all I have to do is just click calculate. And as the time goes, that component starts becoming, changing its state. Let's say after 4 seconds, I want this red pin to also change, so I can hide it completely. Maybe hide all of them. So let me just select them all and click hide. All right, and this is all going to change as the time goes. And not only can I hide and show components, you know, this blue thing, I actually don't like it blue. So let's change its color completely. Let me right click over here and click on material. And from here, I've opened the library of materials I've got. So instead of blue, let's go with something like green, for example. Here's green and hit OK. And I've also got another change bar, as you can see. So if I hit calculate, those parts will be coming transparent and hidden, and this part turns from blue to green as I've specified. So maybe if I don't want that change to happen all the way along, maybe I just want that change to start after 2 seconds. So from 0 to 2, it's still blue, and from 2 to 4, it becomes green. All right, so I've got full control over where everything happens and when it happens using those key points, as you can see. So now, first things, all of these will be hidden, and then this part will start turning green, as you can see right now. And I can do this with more than that. I mean, let's say instead of just making it green, I want to change its transparency. So let me also right click and go to appearances. And from here, let's make it like 50% transparent. So all I've got to do is just go to the advanced tab over here, and from here, if I go to illumination and go down a bit, I'll see this transparent amount. So let's drag it, let's say something like 0.4 or maybe 0.5, something like that, and hit OK. And that's also a change that's also saved in that key point. So with that key point, as you can see, it shows me that the appearance is going to be green and the transparency is 50%, while over here, the appearance is blue and the transparency is 0%. And that's the change that happens over here. But before I start moving to another topic, let's just remember that this actually might happen a bit quick. So let's say I want this transition to be different. So to make that easy, let me just turn all of these off. Let's just focus on this one. All right, so I'm just changing it from being blue to being green and changing the transparency. Right now, if I right click on this, I'll find this interpolation mode, which I said before is the transition between one type to another. And the default is linear. So let's say in 1 second, it changes from 0 to 100%. So after half a second, it changes to 50%. After 0.75 seconds, it starts changing 75%, and so on. But I can actually change it. So snap, for example, it stays the same all until the very last second. So if I change it to snap, it doesn't do anything at all. And at the very last moment, it changes right away. Okay, I can change that interpolation mode to something else, maybe ease in or ease out, or ease in and ease out. So it starts a bit slowly and then speeds up and then ends a bit slowly as well. So if I hit calculate, the change is so slow, then it speeds up, and then the change is a bit slower once again at the very end. And you can start using these interpolation modes to make the movement more interesting and more easy on the eye, because you don't always want to see things just having a sudden change, but when it's a gradual change, it's way more easier and way more pleasant to look at. So that's with key points. You can, as we saw, we can change component positioning, we can change camera positioning, and we can even change some things about the components themselves, whether it's their appearances, their visibility, and so on. So now let's talk about a different thing, which is motors, right? So as I said, usually when you use motors, we've got something that has to go on and again, and you don't want that to happen using mates because it's a bit difficult to set it up with mates. So the first type of motors is, of course, a linear motor, which is like an actuator. It goes and comes back in a translational way, in a linear direction. So I've got a model like this, and this is just a spring that I've set up with this piston. So if this gets down, and if I hit rebuild, the spring rebuilds, and this pointer points to the other direction. And what I want to do is just change this from this position to the other position, And I can actually do this with a mate, let's say a distance mate from here to here, and start changing the value from top to bottom. But let's start doing it with a different way, with a motor. So I'm starting a new motion study, and I'm going to this part over here, which is to add a motor, as you can see over here. So when I click on it, it starts this motor property manager. I don't want it to be rotary, I want it to be linear. The component itself, if I change the view to something like this, it might be easier to see. So I want this, and this red arrow actually shows me the direction. So instead of moving upwards, I want it to move downwards, and it has to move relative to something, so relative to this enclosure that I've put in. And now all I have to do is just set the speed. So I can set it as a constant speed, as a distance to go through, oscillation, all of that. Let's start with, let's say, a distance. So I want it to move in not 5 seconds, let's say 2 seconds. I want it to move, let's say 30 millimeters. All right, and I'm gonna hit OK. And now I've got this motor, as you can see over here. Here's the linear motor. And all I have to do is just hit calculate. And as you can see, it starts moving down one by one as the animation is calculating it. There it is. And if I want it to change it and go up again, what I can do is I can set here a different thing. So I can change some parameters about this motor. Let's say right now I want it to go the other direction. So I'm just going to switch this up. Okay, so in this case, it's going to move up. But you notice that there isn't a key point over here, because what I chose was a different type of motor that doesn't allow me to change that parameters as it goes by. The direction is a main parameter. What I can change is the speed, for example. But if I want to change the direction, there's an easier way, actually. So let me start at the very beginning once again and use a different type of setting speed. So I still want it to move downwards. But instead of going this distance, I can actually say, like, let's say I want it to go a different value, but I want it to be oscillating, to move up and down, right? So now what the distance is about also 30, and the frequency is, as you guys know, 1 over the time. So let's say I wanted to do one full going up and down in, let's say, 2 seconds. So the time is 2 seconds. So 1 over 2, that's 0.5. Okay, so remember, in 2 seconds, it's going to go up and down. So which means that each one is going to happen in just 1 second. If I want to say, let's say 4 seconds just as it is, then it's 1 over 4, that's 0.25. And I can hit OK. And now after 2 seconds, it has to be fully down. And after 4 seconds, it has to be fully up. Let's hit calculate and see what happens. And as you can see, with only specifying that parameter in the new different type of linear motor, now I've got the animation going up and down and up and down, on and on again, without needing to change the direction later on manually by myself. There it is. So if I hit play, as you can see, it starts moving down, and at 2 seconds, it's fully extended. And when it comes back to 4 seconds, it's fully compressed once again. So that's also a different way to specify what the motor is going to change like. There are obviously different ways. So one might say, no, instead of doing that, let's say I want to edit this motor. And instead of it being oscillating, I want to just set it as a constant speed. Let's say 30 millimeters per second. So that means that it's going to go in 1 second, all that 30 millimeters. If I want to go, for example, in 2 seconds, then I have to divide it by 2. So it's like 15 millimeters per second. And you have to do all this math in your head. So that's something to consider when choosing which type of parameters you're telling the software. So let's go with that. And let's just end the motor over here. So I'm going to drag this at the very beginning and stop at only 2 seconds. And now if I hit calculate, it's going to do the same thing. All of these are different ways to tell the software to do the same thing, but the only difference is what way are you telling the software, which parameters do you have that you're giving the software, and based on that, it's going to go ahead and do the animation for you. So that was a linear actuator. Now let's talk about a rotary actuator, where we've got something that's rotating around and around. And in this case, I've got this this chain over here but this is actually a different type of chain, because instead of just rotating at a constant speed, what I want is for some sort of relation to be between this light blue cylinder over here and this red link over here. So if this one rotates like this, I want the other one to follow it, and I already have a mate, a coincident mate between this top plane of this part and the axle of this part. So all I have to do is just set this to start rotating around and around and around, right? So what I'm going to do right now, let me just take it back to the very original position. I'm going to start a new motion study. And from here, I'm also going to go and start a new motor, but this time it's going to be a rotary motor. And what I want to change is this cylinder, and let's go in the other direction. And since it's actually in mid-air, so there's nothing to be relative to, so it's just going to rotate relative to itself. And for constant speed, let's say I want 60 RPM. So 60 revolutions per minute, that's 1 revolution in 1 second. If I wanted to do 1 revolution in, let's say, 2 seconds, so I'm going to go like with 30 RPM and hit OK. And after 2 seconds, I will check it. And as you can see, it has rotated 360 degrees. And now I can just right click and say off. For example, I'm turning off the motor, and I can do actually different things. So you don't have to just stick to one thing to do at one time. So while I'm rotating this component, let's say I want to do something else. Let's say I want this this drive wheel to be hidden, for example. I want this link to change its color. So I can do mixture of all of these things that we've discussed so far in the same animation. So let's say, for example, I want to change it, instead of red, let's make it something like blue. Like that, and I'm gonna hit OK. And now, when I hit calculate, all of these changes will all happen at the same time. So if I set this to go over and over again, so the playback mode is now loop, and hit play, as you can see, this rotates and this disappears, and this turns from blue to green, to red, and red to blue, and so on. So as you can see, I can also add another level of complexity, which is a camera, and start moving the camera around, and so on. All of this can be done in the same animation, as you can see. And as I said before, the limitation is only your imagination. Whatever you think that you can do using key points, whether it's moving components with mates, whether it's moving components with motors, whether it's adding cameras and changing their views, and so on, all of that can be done with animations. So now I've talked about key points and motors, and I did say before that these were the two main ways to create an animation, but there's actually another one, which is the animation wizard. And when you hear the word animation wizard, do you think, it's going to be something wizardry, something new? And that is true, because it does actually save you tons of time. And there are 3 main things about animation wizard that I'm going to talk about today, because animation wizard as a tool, it's got many things that it can do. I'm going to start with rotation. So first things first, we've got these 2 models side by side. Both of them are actually rotating, but the only difference is which of them is rotating in a way that you would find pleasing, you would find looking good. And I'm just gonna leave this as it is and get back to Solidworks real quick. And from here, I'm going to start using the animation wizard to create that rotation that we saw. So here I've got the model, okay? And all I'm going to do is just hit new motion study. And now I'm going to go over here. This is the animation wizard. I'm going to click on it. I want to say rotate model. But you know what? Before I do this, let me just make sure that I turn on the floor shadows of the scene so that it looks good as well. So let me also flatten the floor. Make sure the offset is perfect. And let me also turn on real view graphics so that the shadows are visible like this. Now let's go back and add the rotation. So I'm going to rotate the model, let's say around the y-axis clockwise, and only one rotation, and the duration, let's say in 5 seconds. All right, and hit finish. And And as you can see, it's already created key points for me to rotate this animation. So all I have to do now is just click play, and something weird is going on. Remember, I asked it to rotate around the y-axis, right? Let me just have this to loop and just have it to play. And look at this y-axis over here. Even though I'm supposed to be rotating around the y-axis itself is actually rotating with me. And when you look at the shadow is kind of weird. It's as if I'm moving downwards below the model and then up again, and it just doesn't look right. And the main issue here is that this is created using key points, right? So these are all just changes to the key point view that I'm from. So let's say I want to drag this like here and drag this like here. I'm actually changing the speed of which the model will start to rotate. So here is very slow, here is very quick, and so on. And the issue with that is any edits. So let's say, for example, this is 5 seconds. If I want to make it at 10 seconds, I'll have to just drag this to 10 and manually drag this to 8 and drag this to 6 and so on. And it's just a lot of steps. Or I can go over here to the animation wizard and add a new one. But this time I want it to be 10 seconds. I'm going to go finish. But the real issue here is that it added it on top of the previous one. So this one was from the previous one. This is from the new one, the previous one, the new one, and it's just a big mess. So to save that, I'm just going to click delete all existing paths. So that deletes anything that existed before. And it just starts a new clean one that is 10 seconds, as you can see. But there's also another thing. Let's say, for example, if I go to 4 seconds and I hide one of these components. Let's say I hide this component. Okay, and yeah, the animation is working, it rotates, and that component is being hidden, as you can see. But let's say I want to do something different. I want, instead of 10 seconds, let's go back again and make it 5 seconds. And I'm also going to delete all the existing paths. And here it is 5 seconds. The issue here is that change that I created to the appearance of one of the components, it also got deleted along the way. And now so this was obviously just one change. If I had a whole animation setup and at the very end I started changing the orientation and I decided I want to make it a bit longer, a bit shorter and change that. If I decided to delete all paths, it literally deletes everything. So take that into consideration. And with that said, yeah, it is a quick way to create a rotation of your animation, but it's not the best way. But don't worry, I've got a better idea for you. Remember that we've used cameras before, right? So what we're going to do right now is I've got a sketch set up over here, right? This sketch is a bit above the model, and it's a circle, essentially. And what I'm going to do is I'm going to create a camera, and I want that camera to be on that circle. So the target, first things first, is going to be the origin of my model. Okay, maybe just increase the distance by a bit, right? And when it comes to the camera position, instead of specifying it by hand, all I'm going to do is just tell it be over here, right? Let's do something like this. Now, yeah, now it's centered. So now I've got this slider. If I start rotating this, as you can see, the camera is actually rotating along the path that I presented to the software. So all I have to do now is just start changing the aspect ratio to like 16:9. And that's it. I've got the camera ready. Now I just start a new motion study. And let's say after 5 seconds over here, I change the camera. And all I have to do now is just drag that slider along the way. So from 0, I just want it to be 100% and click OK. And now, as you can see, I'm really actually rotating around the y-axis in a correct manner, and the shadows and the model, everything now looks realistic and looks good. And the best thing here is that instead of making it 5 seconds, let me just make it 10 seconds. All I have to do is just drag this around, and that's it. Now when I play, it's going to work at 10 seconds as well. So changing it right now is way easier. The looks of the model is also way better, and I've got everything looking way more realistic this time. So even though the animation wizard might be a very quick way to create your animation, it's not always the best way. Okay, so the second thing about the animation wizard is exploded views. So in this case, what I want to do is I already have an exploded view of one of my models, and what I want to do is just animate the explosion. So let me just turn off real view graphics real quick once again, and I've got this model over here. And if I go to my configurations, you'll notice I've already got an exploded view. And if I right click and say animate the explode, I can have an animation from here, and I can actually save it from here as well. But if I click on save animation, I'm just going to save it like this, but I don't have much control over it. But what I want to do is actually have this animation inside of my motion study and change other things as well. So let's say I want to change the camera view, or I want to change the components color or stuff like that. To do that, all I have to do, let me just go back again and collapse this. All I have to do is just go to my motion study. And again, from the animation wizard, all I have to do is now choose this option. This option was actually grayed out before because the previous model, it didn't have an exploded view set in it. But since this one does, so this option is now available, I'm just going to click on explode. The duration, let's say I want it to be in 5 seconds as it is. I'm going to click finish. And as you can see, I've got all of these key points created for me by Solidworks. And if I click play, it starts animating all of these key points, as you can see. All right, and let's say I want it to stay for 1 second, and from 6 seconds over here, I want to add a collapse, so it comes back again. So this time, the start time is going to be 6 seconds. It doesn't have to be the same duration. Let's say 2.5 seconds long. And as you can see, I've got that as well. So if I click play, it's going to collapse once again, but in a very faster manner. All right, so now all I can do is, let's say I want to build up different things as well. So I can get at the very end over here, and let's say maybe change something about the view. So instead of looking from this place, I want to look from the top, for example. So when I'm over here, let me go to the top view and add that as a as the view key. And now I'm going to see the animation as it goes from the top throughout the animation. But if I want it to change, then in that case, I have to right click on here and turn off this option. This option is called disable view key creation, which prevents me from creating view keys myself. That's not what I wanted to do. I actually do want to create view keys. So if I stand at the very beginning and do this, now I've got a view key over here. And at the very end, I want it to be, as I said, from the top view. As you can see, now I've been able to create a view key myself, as you can see over here. And now I can turn this option once again. And now if I click play, the camera is moving one by one throughout the animation while it's being collapsed and exploded. So I can, as you can see, add up multiple layers of creating my animation. So I imported some animation wizardry explosions and animation wizard collapses. I can add different things that like change the camera views and change different things as well. All of that in the same motion study, build up layers above each other. But that's actually not all. So let's go back again to our make controllers. And in this case, we're going to talk about something that not many people use inside of SolidWorks. So let's see in SolidWorks first and then get back to the slides. So what make controller is as the name says, it controls mates. It's actually not a new feature. It was released back in 2016, I believe. But the thing is, I've got this model and I've got all of these parts that I want to control one by one. And if I go down here to my mates folder, I've got all of these mates like seat 4, seat 3, all of these are limit angle mates. And what I want to do is just start controlling them one by one. I can do that in the animation, but it's going to take a long time. So instead of that, what I'm going to do is I'm going to go to insert mate controller. And from here, I'm going to use this option to start controlling all of my mates in a very quick manner. So first things first, I'm just going to click on this button, which collects all the supported mates by this feature. And I'm going to talk about the supported mates in a while. But as you can see, it got all 16 of them over here. And I've got all the positions of them, as you can see down here as well. Now, all I have to do is start creating different positions and change the values from one position to another. So let's say, for example, I wanted to create a new position. I'm going to click over here, position 2. And all I have to do now is just change these values. So let's say I want this to be at 45. Like that. Really quick, I can do it for all of them, as you can see. And all I have to do is just remember to click on this update position button, which saves that new change. And now I've got this position 1 and this is position 2. Maybe even I want to do it in a different way. So one yes and one no, one up and one midway down. So in order for me to do something like this in the animation itself, is going to be way hard. So now let's say I want to create another position where they all come back once again. Notice something. If you create a new position, it actually duplicates the current position. So if I want it to go back again, I can just start on position 1 and create new position. And that way it duplicates position 1 at the very end. So I've got position 1, 2, and 3. So 1 is like this, 2, they all come down, and 3, they come back up again. And that's exactly what I wanted to do. But if I want to have multiple positions, I can click on this and I can start rearranging these positions. So let's say I want this to be moved up or down or deleted and such like that. I can configure all of that from here as well. And after I finish, I can come down over here and start specifying the times for everything. So let's say this one, I want it to go down in 2 seconds, but go up in only 1 second. Something like that. And as you can see, it tells me the total duration is 3 seconds. I can even play it right here from inside the make controller. And I can also save it just as I could save an exploded view, but the same issue arises. When I save it from here, I can only save it as it is. I can't add different layers to it. So I'm just going to click OK. And here I've got my mate controller. As you can see, this mate controller 1. Let me just rename it to mate controller Ugandaswug. How about that? All right. And now if I right click on it, I've got this list of positions to go through. So I'm going to go to position 1 right now. All right. And now all I have to do is just go to my motion study. And from here, I'm also going to go back again to the mate controller. But as you can see, the option over here in my animation wizard is now available. I'm going to go next. I'm going to choose my Ugandaswug mate controller. And here's a nice thing. When it comes to importing, I can import it either as key points or as motors. But motors, as you can see, is for motion analysis. But since we're here talking about animation, so we're going to stick to key points and click next. I can specify the start time, but I can't specify the duration. And remember, well, back in the make controller, I already specified the duration of each step. So the first was 2 seconds and the second was 1 second, I believe. So that's why this is grayed out over here. And just click finish. And you don't actually seem to see anything happening. But if I scroll down to my mates folder and open that, you're going to see all of these changes occurring over here. And these were all created by the software by transferring the mates controller over here. And now if I just click on calculate, now I've got the animation built into my motion study. So as you can see, I can start now adding the different levels of things, change the camera view, change stuff like that. It's all possible right now. And doing that, I've saved myself tons of time to go one by one and start adding these positions and change them. And so on. So back to make controllers. Yeah, perfect. So I've got this model over here, and what I wanted to do in general is I've got these balls over here. So let me just zoom out a bit. I've got these balls on top, and I want these to fall down and start going in this roundabout. Okay, but the thing is, if I just start a new motion study, and as we said, I want them to fall downwards. So instead of controlling that falling motion, which is like a distance to to change, sorry, I can do that with gravity. And here's the gravity option over here. All right. So I'm going to click on gravity, but I see this tooltip that shows and tells me that I'm actually in animation. And in order for me to use gravity, I have to be in basic motion. So make sure you change the motion study type from over here. And now all I have to do is just specify the direction of the gravity. So just to make this easier on you guys, I'm just going to turn off the camera view real quick. Okay, and now let's go back again to our gravity motion manager. And the reason is I want you guys to be able to see this green arrow over here. So that arrow specifies the direction of the gravity itself. So in this case, the direction is in the Z direction. So I know I want it to be in the Y direction. And I can even change or flip the direction if I want to. I can make gravity in any way. So let's say I even want to make gravity something like in this direction. As you can see, it's in any arbitrary direction. I have full control over where the gravity goes. But no, for the sake of this one, I would just want it to be downwards. And I can even change the acceleration of gravity. So of course, by default, it's the g of Earth, but you can actually change it to be like something of the gravity of the moon or the gravity of Jupiter, whatever it is that you want to do. So I'm going to okay, and let me just get back again to the camera view, like that. And all I have to do now is just hit calculate. And as you can see, the balls should now be falling and starting moving around, but there's actually nothing happening, because if I start moving one by one, the balls start falling, they're falling, but they just go through my model as if it doesn't see this piece in here. It just goes through along. And that's because I must tell the software that there's some interaction happening between these two components. So what I want to do is something like this. So if I play this animation, the balls fall and they hit this wall and they start falling into this, and then they start falling down over here one by one. So I have to tell the software that there's some sort of contact between these two components and each other. And that's the next thing we're going to talk about right now. So for context, I've actually got a better part to show this on, because when it comes to contacts, remember that when you increase the number of contacts, Solidworks will have to calculate all of that for you. So let's go through this. So here it is. This is the part I'm working with. And all I have is just when I start rotating this handle, these cams will start rotating as well. And these bars will start moving up and down. So let's do a new motion study. And since I'm going to be doing a basic motion, I'm just going to turn off some mates that I had, these mates, so I'm just going to suppress them because I don't need them here. I'm just now working on real physics, all right? And now let's start by adding contacts. So contacts is this button over here. And when I click on contacts, I've got different things to specify. So here I've got the box to set the contacts in. And remember, I've got this option to use contact groups. We're going to come back to it later on. But right now, what I want to do is just start selecting what things I want to be in contact. I'm just going to select everything, Control A, just select everything, because I want to make sure everything is working correctly. And I already have mates that don't need this to be in contact, because I've already have mates that make this vertical, but for the sake of this one, I'm also going to specify as well. And if I go down, I've got 630 contact pairs. So that's how much contacts the software will have to calculate while I'm going. But let's just hit OK. All right. And now all I have to do is just add something to this handle to make it rotate. So I'm just going to add a motor. And in this case, it's going to be a rotary motor. So let me just zoom over here and just choose this. And the direction, let me just change the direction real quick. And I want to move relative to this big boy. And for the speed, let's just say I want it to do in 2 seconds, so 30 RPM. I don't want it to be too long. And that's it. So let me just drag this all the way to 2 seconds. And now, when I hit calculate, this axis will start rotating and the bars will collide with the discs and start moving upwards and downwards, as you will see right now. Obviously, it starts taking a bit more time because it's actually calculating lots and lots of contacts between the components and each other. So it's, as I said, a compromise on time, but you also get realistic or kind of realistic results that you can't get using animation. So the issue here is that the components are going upwards, but I don't see them coming downwards. So let me change something. Here in the solid body contacts, let me just try to reduce this a bit. So let me just remove this and remove this as well. Only the discs and these lines, just to make it a bit easier for the software. So now I'm down to 561 contacts. That's better. And now if I hit calculate, that should be a bit better for me and for the software as well. And as you can see, now it's working better. But the issue is these are moving upwards, but there's nothing moving them downwards again. So in this case, I'll also have to add gravity. And as I said, make sure that the direction of gravity is downwards, as you can see over here. And now hit OK. And now that I've added the motor, the contacts, and gravity, if I now hit calculate, now it should work perfectly, where everything is moving up because it's pushed by the discs or the cams, and the gravity is pulling them down once again, as you can see over here. So now let me just make this work in a loop. And as you can see, now the motion that I need from this is actually done, right? So this rotates, these start moving up and down, these start moving up and down, and everything is perfect. So as you can see, now I've got this, and it did take me some time to get everything working. And I also had to disregard some of the contacts just to make it easier for the software to calculate all of this. But that's not the real thing here. The main point I want to talk about is the time it takes, because as I said over here, contact groups, it starts reducing solving time. So we didn't check out contact groups. So let me get back to the model and start. So what I have to do right now is make sure that I reduce the number of contacts that software has to calculate. So for example, in this group, I'm going to select all of the rods. So, and in the second group, I'm going to select all of the cams. So here's all of the cams in the first group. And to the second group, I'm going to select all of these rods. And now when I look at the number of contact pairs that the software have to go through, it's down to 289. So that's like what, 50% reduction, right? It used to be 560. So I'm saving the software tons and tons of time to calculate this for me. And it's also going to be visible when I hit calculate here. It's going to be way faster than before. Okay, so I believe I didn't turn off one of the tangent mates before, but it's still going to work nonetheless. Let me just see it, yeah. And just like that, make sure the gravity is working and the contact is working. And there it is. Okay, so as you can see, the number of contact pairs that I tell the software to do is way less than before. And based on that, the number of iteration, this is only applicable, I can do it with anything else. So if I go back to the other one I showed you before, all I had to do is just tell that the software that there's contact between all the components, and that's why I didn't want to show it to you right now. It was just going to take a long time to calculate, and we're kind of limited on time right now. But the thing is, when you tell it to calculate lots of stuff, you have to make sure that the device is ready to do all of that for you. All right, and so let me just do it once again using the contact groups. And here's the motor. It's going to rotate around this one. And it was 30 RPM, I believe. And last but not least, I just have to add the contacts. And this time I'm also going to make sure I use contact groups, right? So here it is, all of the rods. And here I'm going to select all the circles. I can actually do that. I can tell the software, hey, go through every single thing, but that's obviously going to take a long time. So here are the URLs. And just like that. So now back again to what we were talking about. Using contact groups, it's going to tremendously reduce the solving time you have. But the other thing is you're not going to see any difference when it comes to the results themselves. So here you've got the grouped and ungrouped side by side, and I myself don't see any difference between them. The only real difference is the time it took to calculate each one of them. And not just that, but let's think of it as a different way. Why should I go through all of this hassle if I can just add some tangent mates or some cam mates and make it in an animation, right? So here it is side by side, and you can see that the one using mates on the right is way smoother, but that's just not realistic enough, right? Because we know that in real life there isn't something that's going to move that smooth. It's probably going to be some frictions between the components. The contexts are not always going to be 100% correct and stuff like that. So that now depends on what you are trying to show. Are you trying to show something as realistic as possible? So in that case, you got to go to basic motion, or even go to motion analysis, where you can specify in each contact the type of contact it is and the type of friction between the components and stuff like that. Or you just want to show the idea of how the thing is working and do that using mates and just an animation as usual. So as I said, both of these are available to do the exact same thing. The only difference is the time you have, the end result or the end goal that you're after actually is. And now let's talk about the main thing, which is if I create an animation and it's perfect and everything's awesome, but I still want to show it to you. I'm not going to send you the CAD file or the assembly and tell you to play the animation. I have to export it as a video. And there are tons and tons of options that you have to go through in exporting. And they actually might not be that important to many of some things to take into consideration right now that will change tremendously how the animation looks at the very end. So the first thing I want to talk about before we go into those options is that if you have something that changes its geometry throughout the animation, you can only do that with animation. You can't do that with basic motion or motion analysis. So whether it's the model where there was a spring that was rebuilding before, or the one you see down here, which is a port and a ratchet, what Solidworks does is that it rebuilds the model on every single frame. All right, and that's something it won't be able to do with basic motion or motion analysis. So if you need something like that, where these arms actually deform and change their shape and stuff like that, that can only be done when you're using animation. The other thing is, even if you're using animation and you've got something that's changing like that, but if you're rendering the animation using PhotoView 360 or something like that, you won't be able to do that as well. It has to be a still geometry. So PhotoView 360 was because it's already discontinued from SolidWorks 2024, but it was a image rendering add-in that came with SolidWorks Premium, I believe SolidWorks Professional as well. But as long as you're making animation that has changing components where the geometry itself is changing, you won't be able to do that with PhotoView. Okay, enough of that. Let's talk about the animation options. So you don't always have to export your animations as a video. You can actually export it as a series of images. So every single frame can be saved as a separate image, and we're going to see how to do that in a moment. And you can also make sure to focus on two parameters in exporting your video: resolution and FPS. Resolution is, in general, how many bits there are in the video. So let's say, for example, an HD video is 128 by 720. A full HD video is 1920 by 1080, and so on. You're just increasing the number of pixels in the video. So obviously the more is the better, but that's not always the case, because sometimes you just need something to be really quick, and increasing the number of pixels will take longer times to export the animation for you. All right, and maybe you're presenting your video on a full HD screen, so you don't need to go with a 4K video and stuff like that. And the other thing is FPS, or frames per second. So that's how many frames are there in 1 second. And the thing here is, if you go a bit too low, then you end up with choppy motion, or motion that's not so smooth. So let's say if I'm moving my hand like this, right, it's smooth. But let's say if I'm moving it at 3 or 4 frames per second, and you see it like this, and then like this, and then like this, you don't see the smooth moments in between. So also make sure that you don't use the default values for either the FPS or the resolution. Make sure you set the correct values yourself. FPS can be anything. You can choose like 30 FPS is probably the standard, or maybe 24 as well. 60 is for smooth animations when you really do need all of that detail, but choose anything in between. Just never go with the default from SolidWorks, because that just doesn't look good at all. And the main thing as well we're going to talk about, which is video compression, which is something that affects the file size that you have, and also as well the exporting times that you end up with. So to see that, let's get into this animation over here. And before I play the animation, let me just real quick open SolidWorks. And in SolidWorks, I'm going to show you how this animation actually looks. So here's the animation. It's actually pretty simple, not much details in it. And here's the motion study I've got. And when I come to save an animation, all I have to do is just come to this button over here. And if I click on it, I can now see this dialog box, which tells me where you want it to do. So let me just go to the desktop. And from here, I can change the type. So let's say I want it to be a video file. I've got these video formats, and I've got these series of, and all of these are series of images. So let's say I want to save it as bitmaps or JPEGs or PNGs. Every single frame is going to be saved as its own image. So let's say I want it to be a series of PNGs, for example, right? And I can also change the aspect ratio and the image size. So image size here, which is the resolution. So let's say, for example, I want the aspect ratio to be something custom. So I'm going to go with like 16:9, or I can specify the camera aspect ratio, which I'm using inside of this animation. So I can set it to that as well. But now when it comes to this value, let's say if I make this 2000, the other is going to be 1000, and so on. Usually you want to go with something like 1:1 or 16:9. These are the default values that will work on anything. So let's say, for example, 1920 by 1080, that's a very famous one, which is full HD, or maybe 1280 by 720. And finally, the frames per second, 7.5, never go with that. That's really, really bad. Just try to use a different value. Let's say 30 for this one. And here I can change how long do I want to export. So instead of the entire animation, I can save a single frame or a time range. So let's say, for example, I wanted to save it, in this case, from 2 to 4 seconds or something. So, or maybe from 2 to the end, right? But remember, I'm here saving it as a series of images. So let me just save 1 second just for the sake of showing you. And remember, in this 1 second, I'm going to end up with 30 frames, right? So I'm just going to click save. And as it goes along and starts creating all of these images for me, if I go to my desktop, as you can see, I've got all of these images being generated one by one. All right. So it's obviously going to go through all of the 30 images and create them for me. And these I can use later on. Let's say, for example, if I've got a GIF that I want to create, right? So I can take those images and convert them into a GIF, for example. But let's just open one of these real quick and see that it's just one by one, the parts start moving as in the animation, as you can see over here, right? But there's something else that you can do when it comes to saving animations as images, which is to change the compression, as I said. So when it comes to compression, when I go to MP4 or AVI or FLV, these are all video formats, right? So let's go with AVI first things first, because this is the one that really does have compression. And let me just set this to something like that. All right. And when I hit save, it doesn't just go ahead and start saving. It tells me which type of video compression do you want. So here I've got control over the compression quality, whether it's like the default is 85, I can drag it all the way to 100 or to 0. Let's just leave it at the default. And now I can click OK. I've got obviously different compressor engines. These are based on the things that are downloaded on or installed on your device. But I've also got this option for full frames or uncompressed, where it does no compression. It just saves the video files without compressing it at all. Obviously, as I said, that changes the file size that you end up with. So let's just go with the default and hit OK. And now it's going to go ahead and start saving the video. Let me just stop that because I don't want to take too long. And here's the video that I end up with, as you can see as well. All right, but that's with AVI only, because if I go and hit save, and then I go to MP4, here's MP4, if I click save, it just doesn't ask me. It just goes ahead and starts exporting the video once ahead, because when it comes to MP4, it already has a correct balance between the file size and the exported video size. So as you can see, it just created it once without even asking me what kind of compression you want. And this is the thing we're going to talk about here, which is when it comes to compression, I've got here a comparison between three things. The MP4 is on the right, the fully compressed AVI is in the middle, and the uncompressed AVI is on the left. Now let's see how each of them work. So remember, these aren't artifacts because the internet is choppy or anything. This is actually how the video looks. The fully compressed AVI does look like that. You've got artifacts everywhere. The color isn't correct. The quality of the image isn't also correct, and so on. The MP4 and the uncompressed AVI, they look way better. And the main thing here is that you don't see those artifacts at all. All right. But as I said, you sacrifice the export times and the file size. So now let's talk about the file size, because this is what you get in terms of file size. The uncompressed AVI is 292 megabytes. That's over a quarter a gigabyte. All right, so that's a massive video for just a 4-second animation. Remember, this is only 4 seconds long. The fully compressed AVI, on the other hand, is only 1.5 megabytes. So that's way smaller. But on the other hand, the quality is just nah, you don't see any good details. And to be honest, I'd never go with a fully compressed AVI. And when it comes to MP4, the same 4-second animation was only 23 kilobytes. Remember, kilobytes, I'm not talking about megabytes, I'm talking about kilobytes. That's 1,000 times smaller in terms of scale. So since the MP4 and the uncompressed AVI both gave me similar results visually, but in terms of the file size, we're talking about like what, 1 million times bigger or what? So I think it's a no-brainer to go with MP4, because MP4 already has that correct balance between the file size and the quality that you get from the software. On the other hand, AVI, if you're not tuning that compression correctly, you're going to end up with very big file sizes or small file sizes, but not that good quality at all. So that's all for today. I know it's been a long session, but time for a Q&A. I'm going to go through the chat right now and see if I've got any questions in there. But in case you didn't get to send me a message, feel free to scan this QR code and get to me, reach out to me on LinkedIn. I've got an open profile, so anyone can send me a message for free without even having LinkedIn Premium and that kind of stuff. It's all easy. So I'm just going to leave that over here while I go through the chat. And if I don't find any questions here, feel free, guys, to open your mic and ask me your questions as you want. So I don't seem to find any questions here in the chat. So remember, guys, if you've got any questions and you don't have time to send them today, or we don't get to answer your question, I'm always available. Just send me your questions on LinkedIn. I'm going to get back to you. I'm just going to wait for a couple of more minutes, checking the chat. And as I said, you don't have to send in the chat. Just feel free to open your mic and send me tell me your question.